Welcome to Coach Eichner's Math. Today we will be talking about Pythagorean's Theorem. First thing you need to know is when two of three sides of a right triangle are known, the third side can be found using Pythagorean's Theorem. Pythagorean's Theorem was the square of the hypotenuse is equal to the sum of the square of the legs. Written in math terms, hypotenuse squared equals a leg squared plus a leg squared, where these would be my legs, and this would be my hypotenuse. Now, the way that we typically think about this is we typically say c squared equals a squared plus b squared, where c has to be the hypotenuse, and it does not matter what we name a and what we name b, because they're both legs, so they're interchangeable. Again, we'll put this in this box right here. Your Pythagorean theorem is a squared plus b squared equals c squared. Just using my law of symmetry to flip which side of the equal sign we're on, no big deal. So if I'm looking down at example 1, it says find the value of x. Now in the first example, first case, I've been given 3 and 7. The hypotenuse is always across from my 90-degree angle, so x would have to be c. Does not matter which side I call A and B, so we'll say A and B. My formula is a squared plus b squared equals c squared. A is 3, so 3 squared. B is 7 plus 7 squared equals x squared. Doesn't matter, I could have left c as my variable. A variable is a variable, and it doesn't matter which letter we use. Since they already had it labeled as x, we will go ahead and plug in x today. 3 squared is 9 plus 49 for 7 squared equals x squared. That is 58 equals x squared. Now, like we talked about the other day with our radicals, the inverse of a square is the square root. So to get x by itself, we're going to take the square root of both sides, and we can say x equals the square root of 58. Now what we want to do with this is we want to take it one step further and simplify my radical. So 58 breaks down, and I can say that 58 breaks down 2 times 29. Well, 29 does not break down into something easier for us to deal with. So there won't be any pairs that we can pull outside the radical, so we're just going to leave it in the form radical 58 equals x. Looking over at the other side. Looking at example 1, still we're going to look at 6 and 6 square roots of 2 and x. Well, this time across from our 90-degree angle we have 6 square roots of 2, so that has to be c. I'll go ahead and label a as 6 and b is x. So we're going to use the same formula, a squared plus b squared equals c squared. So 6 squared plus x squared equals 6 square roots of 2 squared. So on this problem, 6 squared is 36 plus x squared equals, now in this case we have to distribute that square, so I'd say 6 squared times the square root of 2 squared. Well, 6 squared is 36 times the square root of 2 squared. The square root and the square, again, are inverse operations, so they cancel each other out. I'm left with just a 2 there. So 36 times 2 is 72, and I can just pull everything else down. 36 plus x squared equals 72. Subtract 36 from both sides, x squared would equal 36. And again, inverse operation of our exponent is our radical. So I'm going to take the radical of both sides, the square root of both sides, and I'm going to say that x equals 6. I was able to break it down to 6 because 36 is just 6 times 6. So square root of 36 is another way of saying the square root of 6 squared. So now let's look at example 3. What if, like example 3, I don't have a simple triangle? There's no difference in what we're doing. We're still going to find x. It just takes an extra step to look at and recognize that I can draw a line right here to create a rectangle and to create a right triangle. Now, because I did that, I can say that since 8's over here, 8 would also have to belong right here. 5 on top, it would also be 5 on the bottom. Well, if it's 5 on this part, that means 11 minus 5 would give me 6. 6 would have to go for the bottom leg of the triangle. So again, across from my 90-degree angle, x is c. We'll call 8a and 6b. Got our formula, a squared plus b squared equals c squared. 8 squared plus 6 squared equals c squared. This time I'm going to leave it as c for now, just because I want you to see we can work with other variables and it doesn't matter. 8 squared is 64 plus 36 equals c squared. 64 plus 36 is 100, which equals c squared. Again, I've got a square. The inverse operation is this square root, so I'm going to take square root of both sides. They'll cancel out on this side. I'm leaving me with c. Over here, 100 splits up into 10 times 10. Well, I've got a pair. That's the same thing as me saying the square root of 10 squared. Well, again, now I have the inverse. I have a square root and I have a square. So it would cancel out and leave me just 10 would equal c. And that would be my answer, because c is x. Again, giving us different pictures. Flipping over on the back side, example 4. Now they've given us a square. How do we know it's a square? They tell me that I have right angles, and they tell me that all 4 sides are congruent. You should remember this from our quadrilateral unit, that you should be able to recognize that this is a square. So, they tell me the diagonal is 5 square roots of 2. They tell me one side is x, which means that all 4 sides would be x. So if I go across from my 90-degree angle, right here, I would say 5 square roots of 2 is c. A and b would have to be x. So I'm going to use the same formula. A squared plus b squared equals c squared. So x squared plus x squared equals 5 square root of 2 squared. Notice how I'm still putting parentheses there to make sure I distribute my exponent to both parts of that number. There's always an invisible 1 if there's no number in front, there's no coefficient in front of my x squared. So 1x squared plus 1x squared is 2x squared equals, well, 5 squared times the square root of 2 squared. Distributed my square across the parentheses. 5 squared is 25. Got the square root and the square, which are inverse operations, which means they cancel out, leaving me with just 2, equals 2x squared. At this point, 25 times 2 is 50, which equals 2x squared. Divide by 2 on both sides. Cancels out over here, leaving me with x squared equals 25. Again, I want to get rid of an exponent, and the best way to do that is to take the square root of both sides, as that is the inverse operation, leaving me with x equals 5. Because 25 can be split up into 5 times 5, which is another way to say square root of 5 squared, which are inverse operations. So looking down below at number 6, if they give you a problem and there are no pictures, the very first thing we need to do is draw a picture. So in this case, find the length of the diagonal of a square with a perimeter of 24. So I need to draw the picture that I see above. Because it is a square, and I know my square is not perfect, that's okay. This drawing is for us, and it doesn't have to be perfect. So I know that I've got my 90-degree angles. I know that all 4 sides are congruent because they told me it was a square. And I know that the perimeter is going to be 24. Well, remember, perimeter, we're just going to add up all the sides of the shape. So in this case, the perimeter of a square is 24. If I divide that by the number of sides, 4, it'll tell me how much each side of my shape would be. In this case, 6. So, now that I've got my sides, I need to find C. I've got A, I've got B, so now I need to find C. Again, it's a squared plus b squared equals c squared. If you don't have this memorized by now, you might want to get that taken care of. 6 squared plus 6 squared equals c squared. So 36 plus 36 equals c squared. 36 plus 36 is 72, which equals c squared. Again, trying to get c by itself, do the inverse operation of both sides. C equals the square root of 72. Well, 72 will break down. 72 is 2 times 36. Well, we've already worked 36 before. We know that 36 is just 6 times 6. So, I can say that the square root of 32 is the square root of 2 times 6 squared. And that's going to equal c. Well, the 6, because it is a square and the square root, cancels out and moves outside. So that is 6 square roots of 2 equals c. And that is your final answer. Should be starting to notice a pattern, and we'll work more with that pattern, seeing the square root of 2 ending up here on a square root of 2 ending up on problem 4. We're going to start working problems like that a little bit later on, but it is important that you start recognizing there's a pattern. If it's a square, the hypotenuse or the diagonal of the shape is always going to be with the square root of 2 involved. That's something that you'll see more of as we get into this later. Find the value of x in the isosceles trapezoid shown below. So again, just like before, we know we have a rectangle in the middle. We know it's isosceles trapezoid because my two legs of the isosceles trapezoid are congruent. And I know that the small base, 10, transfers to the middle over here and would be the small base in the center, but it still leaves me without the short leg of my hypotenuse, or short leg of my right triangles. Luckily, I have my hypotenuse of 10, which is C. I have the short side, which is B, and I can find my missing side of A. So I'd say a squared plus b squared equals c squared. And now just to work with numbers for a second, work with variables for a second, before I ever put my problem in, I know I'm looking for a. So right now, if I want to look at it, I can say minus b squared to both sides. And we need to be able to recognize that I can set it up a squared equals c squared minus b squared. So, looking for a squared. C squared is 10 squared minus 8 squared, and that equals a squared. Well, that's 100 minus 64. 100 minus 64 is 36. So a squared equals 36. Now notice, again, we're in the same situation. We've got a square. We want to take the inverse operation of that square to cancel it out. And a equals 6. Just like before when we saw the 36 was 6 times 6. Same idea here. We've got 6 squared. We can just cancel out the radical and pull it outside. A would be 6. However, that is not the end of my problem. I have to go back and plug in that a is 6, and a is 6, because I have two congruent triangles that I have to do that for. So that means for x, I have piece number 1, which is 6. I have piece number 2, which is 10. I have piece number 3, which is 6. So I need to add all three of these together, and I would say that the value of x is 22. And that would be your final answer. I hope you've enjoyed. Hope you have a good day, and we will talk again soon.